Hello, welcome back to the continuing lecture in investment analysis. Excuse me. So, um, um, so we all understand now it is inevitable that uh, the to operationalize capm, right? We have to use index model uh, as as well as with uh, excess returns as the variables to estimate. As a regressor and regressant. Um, so the specification, in other words, index model would automatically already include the excess return form of the regressor and regressant variables, right? And It has to be the actual returns data. Uh, so if you, so this is, basically the specification of the index model as we know it, right? And then uh, we um, basically understand what these, coefficients or parameters are uh, telling. Um, of course, the error terms or the residuals are the uh, firm-specific risks or firm-specific effects. And and we are basically then running regression of uh, the the excess return on a particular stock and the excess return on the market, and then the estimated result will be estimated coefficients will be beta and alpha, and the resulting regression line is called the security characteristic line. Now, we already know what security market line is. So security characteristics line, the security characteristic line is something similar to security, market line. That's, but then, there's a slight difference. Remember, in security market line, the horizontal axis is beta, right? The horizontal axis is the beta. But in a security characteristic line, the horizontal axis is the market excess return. So in other words, let me just take you back to the security market line. In the security market line, the vertical axis is the expected return, and the horizontal axis is beta. Whereas in the security characteristics line, tongue twisted, security characteristic line, the horizontal axis is the market excess return, and the vertical axis is the individual stocks excess return. And that's obvious why it has to be that way, because we are regressing uh, an individual stock's individual stock I's excess return over or against the market excess return. So that's why I'm sorry. That's that is y variable, and this is x variable, right? So that's why it is, horizontal axis and the vertical axis. Now, and if we take the expectations operator on both sides, because capm is eventually about expected return, and expectations operator automatically means expectations operator means what? What is expected something? Expected x is the mean of x, mean value, because um, uh, expected return is another name for mean return, because the forecast will give you what is the best forecast given the past data. Best forecast given the past data is the mean of uh, the past data. Of course, this expected return is not, is the result of, regression, not, really just the mean of the past return, right? It is, actually, if you run regression, right, and this will become the required return. But in equilibrium, on security, if everything is on the security market line, the required return is exactly the expected return. I mean, I'm going to come back to this later, but theoretically, I'm trying to uh, you know close the gap between the theory and practice, right? uh, and, uh, and if we take the expectations operator, right? Of course, risk-free return is a constant, right? There you don't need to uh, you don't need to take any expectations operator on because think about it. Uh, Treasury bill is known. It's not on expected value, right? Whereas market return can if you take the expectations operator, right? Um, uh, it will be the mean return of the market, and then this will be a white noise, right? This term, error term, mean of the error, terms, uh, if and error terms are normally distributed. We assume normal distribution, right? In error terms, so error terms, mean of the normal distribution, and standard normal distribution is zero. It's called white noise, and the reason we can assume white noise is that if the errors are normally distributed and homoscedastic. Homoscedasticity is a statistical term for errors distributed evenly, right? And from coming from even distribution, right? uh, the opposite term is heteroscedastic. But if the errors are, there is no reason to assume that the errors are skewed. I mean, what it means is, some errors are positive, some errors are negative, and they are relatively evenly distributed, right? Uh, then the average of all these errors will have to be zero because uh, the positive uh, errors will cancel out with negative errors. I mean, this won't be the case only if, let's say, positive errors are all between, 0 and 5, and negative errors are all between, 5 and 10, negative 5 and 10. Obviously, they cannot cancel out. But if they are uh, normally distributed and coming from, homoscedastic normal distribution, then the positive errors will pretty much cancel out negative errors, right? In other words, the distribution of errors will be, I don't know if I can, is there, uh, yeah, let's take a look at, this regression line or SCL. Um, this is market excess return, and this is Google's excess return. Look at the error distribution. Of course, you can tell. I mean, just looking at this, it looks like errors are more densely populated below the regression line, and less densely populated above uh, regression line. But overall, I mean, if we extend this, if we extend the data range, I don't know uh, how many months it contained, but in a long run, I mean, usually they use 5-year time frame. Uh, uh, I don't know how many months, the data came from, maybe 60 months, because normally, 5 years. They use 5-year time frame. But if you look at like, longer, this doesn't look like they are like evenly balanced on both sides. But uh, if you're on a longer, long-term, long-run time frame, uh, this error distribution would look more even, and it's not like this distribution is skewed, a lot uh, to the positive side or skewed way to the negative side. It's just, pretty much, coming from within uh, even, space, right? Space of, uh, 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 data values, right? Now, so then this becomes zero, right? This falls out, in the in the world of the means, right? The error term, expected mean, expected, residuals will become zero due to white noise. And then we can rewrite the index model this way because we already know this is excess return, excess market return, right? And then uh, the error is, clearly residual from regression. What, systematic and abnormal return, systematic, component and abnormal return uh, cannot explain whatever is left. That's the residual. Uh, so in that way, 7.4 converts into equation 7.2. I think into, and remember I told you to remember what 7.2 uh, what 7.2 was, and 7.4, this is 7.4, right? And then, in other words, uh, the index model form, in other words, excess return form, and then the 7 point, and 7.2 is basically the the capm specification, this one, right? Okay. Um, if alpha is 0, and then if alpha is 0, uh, it simply becomes expected return on stock I is RF plus beta, right? Times RM, expected return on market minus risk-free return, right? I'm trying to find 7.2 because that is, okay, maybe it was in the previous chapter, but that's, oh, here, 7.2, right? That's what it is. Um, so, um, so if he successfully put it into a operational form, right? Then we're gonna run some tests, right? Uh, we're gonna come back to that. Table 7.1, that's the summary statistic, summary statistics of this operational model or operationalized model. Now, however, if alpha of the regressions is significantly different from 0, uh, even when you use the excess return form, right? Excess return specification, if you still get significant alpha value that is significantly different from 0, then it could be, uh, is it because you chose a bad index to proxy the market, or is capm not useful? Now, actually, in reality, uh, persistent positive significant alphas are often observed, uh, and it falls into one of these categories. Either it's small stock or large stocks, right? Small stocks generally have significantly positive alphas. Large stocks, I mean, would have a relatively uh, smaller alphas or insignificant alphas, and stocks with unexpectedly good recent earnings, stocks because recently it has really good earnings, right? Um, then obviously will be reflected in the positive alpha. Stocks with high market to book value ratio. High market to book value ratio already represents what? Uh, Overvaluation of the stock, overvaluation. Stocks are overvalued in this case. High market price to book value. Book, you know, Actually stocks are, such a stock is overvalued. And stocks with momentum that experienced recent increase in price. Uh, Momentum means, actually, it's a uh, short-term technical analysis, uh, uh, technical analysis, uh, metrics such as moving average, MACD, moving average conversion diversion, but we don't have time to go into that at this point. Uh, but it will be a separate topic. Now, in general, however, future alphas are practically impossible to predict from past values. Let's think about it. So the result, index models are still widely used to operationalize capm. So I don't know if this is Google. Yeah, it's Google. Yeah, Google. It says Google. I thought it was Google, but so let's take a look at it's like 4 year. It's 5 years. 5 year data. Monthly data because it started from January of 2006 and covers all the way to December 2010, right? It's full 5 years, complete 5 years, right? So over 5 year period, you would have, if you're using monthly data, uh, there will be 60 data points, right? Uh, and the summer result of the summary statistics, this is not actually uh, regression summary, right? It's just a few select uh, uh, parameters that we got from Google's data over the last, not the most recent past 5 years, but this was already like 10 years ago, but still it will shed light on what we are trying to understand. First of all, average rate of return of T-bills was 0.184%, and S&P 500 was 0.239 average monthly, right? This is monthly, right? Google 1.125. Average excess return, of course, it doesn't have any excess return because T-bill minus T-bill, and this minus T-bill would be this, right? You can just verify. It's not that difficult. And Google's, average excess return, this minus this, so it will have to be this. Standard deviations, we got that. And geometric average, over the last, 60 months, right? We got that. Cumulative total 5 year return. This is, total return or the holding period return. T-bills 11.65, S&P. Interesting thing is, if you look at the T-bill, average return and the standard deviation are pretty much close, very close. And if you're taking the Sharpe ratio of S&P 500, you will see the Sharpe ratio won't be that high. Maybe taking the price of risk. It's not price of risk, this over this squared, right? And that would be more easier to understand. So cumulative 5-year return for Google, wow, 43%, right? Not that bad, but not definitely a fast growing company. I mean, fast growing company would even reach 43%, something like 40% level, in just within a year, or in just 6 months, or now breaking it down into sub periods, like each 2-year sub period. I mean, this is the last one is just 1 year. Or 1.5, I see, because it's January through October, November through May, June through December. It's like, and you can tell November 2007 through May of 2009, which is right after the financial crisis. Look at the S&P 500 standard deviation. Google, every company suffered. The market suffered. Google suffered. Look at the standard deviation. Negative, right? Negative. And actually, you might wonder, variance would always be positive no matter what, right? Because it's always squared. I really want to look into these numbers, actually, because a standard deviation is both ways, right? I mean, if there is a lower, if there is a negative side, right, there should be a positive side too. So I got to check this number. Now, but before the oh, this is not, I'm sorry, this is not standard deviation. This is the gain. So obviously, during this period, negative return, quite, obvious. But right before the financial crisis, they had this, S&P 500 was doing, during this 2-year period, right, doing this good, right? And Google was doing, 70%. And then it lost, 40%, and pretty much, seems like, in the ensuing following 2 years, it they seem like they have regained, right, what they lost during the 2 years of the recession, right? So this is the interpretation of, effect of financial crisis was so severe, right? S&P 500 monthly geometric average return was 0.107, which was even less than T-bills return, right? And the arithmetic average was even greater than geometric average, which is normally on normally not happening, with difference increasing with volatility. Monthly, a standard deviation of the market was 5.11%, which was large enough, right, for 5.11, right? There you go, standard deviation. That's a bit fun. Nonetheless, market's monthly arithmetic average was 0.239%, which is greater than T-bills. So obviously that means positive excess return market, right? Positive market premium, right? And Google's 5-year return was 43. We saw that, which is greater than definitely T-bills or S&P 500. Google's monthly standard deviation was 10.4%. 10.4, right? Which is like 2 times the market's standard deviation. So we would wonder how much of that is due to systematic risk. In other words, how much of that volatility is systematic. Now, Google's return increased, was high pre-recession, right? But Google lost, during the financial crisis and gained the recovery, right? During the recovery period, 42.36. And Google, they seemingly offset each other by similar magnitudes, but should they have just about canceled out? This is something we need to look into further. And we are quite out of time, so we cannot. I think I want to, even if it is, even if it takes 40 minutes or more. Let's keep going. Yet total 5-year cumulative return is 43.17, which is less than pre-recession gain of 70.42, right, by roughly about 27%. So the 27% just vaporized, right? It went into crisis, vaporized, and the loss and the gain had a total impact on cumulative return of, during the recession, it lost, right? And then post-recession, it gained like about this. So, and they did not exactly cancel out. It was, about, if this is 1, then, it canceled out. But the loss was about 6%, right? So apply if we apply this to pre-recession values, right? 1.43, it gives us 1.43, which is just about equal to 5-year cumulative return. It comes out, right? Which is just about 5-year. So why didn't 40.99% loss and 42.36% gain roughly cancel out? In general, a large increase following a large drop has a muted impact on the holding period return. because it acts on a diminished investment base. Diminished investment base. In other words, while a large drop following a large increase has an amplified impact because it acts on a greater investment base. In other words, the greater the fluctuation, the greater the impact on final investment value. So why spread between why and that's why there's a spread between geometric average reflecting cumulative return and arithmetic average increasing with volatility. Now, so now these two paragraphs, these two bullet points, you can easily understand what that means. When you lose 50%, let's suppose you have $1 million, right? And let's say you lost 50%, and that's $500,000, right? To regain, to get back to $1 million, you have to gain more than 50%. Isn't that right? Because from 1 million dropping to 500K is loss of 50%, but from the 500K, which is a smaller base, right? To get back to 1 million, the growth has to be 100%, not 50%. Make sense? That's if you just grow from 500K, if you grow 50%, you just get to 750K, not 1 million. Make sense? That's the muted effect because same growth rate cannot get you back to the old previous level, right? Actually, considering the 40% loss in considering the 40% loss during the recession years, growth in the 42% growth in the post-recession years, post-crisis years, was a good growth. Actually, although there was muted effect, it was clearly a good growth, right? But still, not enough to really cancel out that, the 40% loss in the recession years, right? So 42%, although it is 42% gain, right? But actually, it was actually it was not a full recovery. You still lost 16% overall, right? Makes sense. Still lost, you're still short. All righty, so that's it for now. I'll have to stop the video, stop recording, and I will see you guys in the next video. Stop recording.